Namaste everyone. So today we'll see the laws of reflection. So these are easy laws which you have learned already. So the first one is the angle of incidence is equal to the angle of reflection. So we write this as angle I equal to angle R. So angle I equal to angle R. The second one is the incident ray, the reflected ray, and the normal to the surface at the point of incidence. So all the three lie in the same plane. So that's the second law. These two laws are very much important for reflection. So based on the first law, there's a question like this. In regular reflection, the reflection which takes place on the plane mirror or any kind of polished surface, we see that angle I is equal to angle R. So here it obeys the light obeys the laws of reflection. Does it obey the same law when it falls on an irregular surface, just like in diffuse reflection? Yes. Here also the laws of reflection holds good. The only difference is that, so since due to irregularities, the surface on which the light is incident is different, and like for each ray which falls when it touches the surface, there are some irregularities or difference in the angle in which the light strikes the entire surface. As a result, the light is reflected in different directions following the same laws of reflection. So the next one we'll see the characteristics of image formed by a plane mirror. Plane mirror is nothing but the mirrors which you have in our houses. So I'm going to, before we see the points, just we'll try to understand it from the diagram which is here. So the characteristics of image formed by the plane mirror, I'm going to show you these points. So here it is. Now from this diagram, so what you can observe is, so this is the object in front of the mirror, and that's the image. Both are of the same height. So object and image are same height. That's the first point which you have noticed. Then the second one is the distance of the object from the mirror is same as the distance of the image from the mirror. So object, how far it stands in front of the mirror, the same distance the image will be formed behind the mirror. So you can say object and image, the distance is same as the object in front of the mirror, the image behind the mirror. Then next another one what we can notice is, so most of the time it's always that the images will be formed behind the mirror. So it's always behind the mirror. So such an image which forms behind the mirror and which cannot be obtained on screen is called virtual image. So always virtual images are formed in a plane mirror. Then another point which we can notice is, so whatever the hand, see here, this is the right hand on this direction, that becomes that is the left hand. So right left inversion, this is called the right left inversion or lateral inversion. So that is what we can notice. The last one which we have to or we notice is, so if a person is standing straight, the image also appears straight. So it does not appear inverted. So you don't get inverted images. So always it's an upright image. Upright image. So these 5 points which we easily notice from the plane mirror. So object and the image are of the same height, and the distance of the image is same as the object in front of the mirror. And the another one is always virtual images are formed in the plane mirror. And then there is a left right inversion which we call it as lateral inversion, and we can also see that the image is always upright. I'll put the points in front of you. These are the points. The image is formed behind the mirror and has the same size as the object. Image is laterally inverted. Behind the mirror is nothing but a virtual image. Laterally inverted is the left right inversion. So images are far behind the mirror as the object in front of it. So the distance. Then the next one is virtual and it cannot be obtained on screen. Then we have the image which is erect. So it's always erect or upright, we can say. Both are correct. So the next topic is So this is very important topic in art and standard. Spherical mirrors. Spherical mirrors are nothing but they are a part of a hollow sphere. So they are obtained. A spherical mirror is obtained by taking a thin part of a hollow sphere of any glass. That sphere is made of glass or a metal. So let me consider this hollow glass sphere. So whenever we are taking a spherical mirror out of it, what we are going to do is we are going to cut some part in a circular shape. So like this. So these are the parts of big sphere. So I'm going to cut some small parts from it. So okay. So I have cut three parts out of it. So what I'm going to do is if we bring this part which is cut, so this part appears to be like this. So please follow here what I'm drawing. That is the one which we have cut and brought it out. Now the side view of this part will be, so I'm going to draw the side view of this part. So the side view of this part will be like this, somewhat like this. So because we have cut it, that hollow shape gives the side view of this one. So I'm going to bring this one out. So and then we will see the side view of this. So that's actually the part which is cut from the hollow sphere. So I'm going to turn it and the side view of this will be like this. So this is cut from a hollow sphere. So they will have a side view like this. So to have better understanding how the side view will be, I have put one more diagram in front of you. That is one more example in front of you. So you can imagine this one, an ice cream cup in the shape of a ball. So this is like hollow. You can take this one as hollow glass sphere. From this, the cap which is there, you can consider it as a spherical mirror. So the spherical mirror is nothing but the one which I am going to cut and take it out. So you can see the shape of the cap. The shape of the cap is something like this. And then when you open it, so the cap will be like this. So it has the shape like this. So that's the top view of the cap which I have drawn. So the mirror is almost the same. You have the spherical mirrors. So that's the side view. Now we got two mirrors. Now we have chance, like we can make the reflecting surface either inward or outward. So to make the reflecting surface inward, what I'm going to do is I'm going to apply some metallic coating on the outer surface. So that's the outer surface. So or we can say bulge surface. On the surface, if it is made it as rough by applying paint or metallic coating. Now what happens? The inner one will become the reflecting surface. Now the reflection takes place from the hollow surface inside the mirror. Now I have another one. What I'm going to do is I'm going to paint the metallic coating inside the hollow surface. Now this hollow surface becomes the rough one where it is covered with the metallic coating as well as some paint. Now this bulged surface will be the reflecting surface. Now we have two kinds of mirror. So if the surface is inward, the reflecting surface is curved inward. So such a mirror is called concave mirror. So the reflecting surface is curved inward. Now if the reflecting surface is bulged outside, such a mirror is called convex. Convex, always you remember, it's a bulge shape. Bulge shape is convex shape. Now two kinds of mirrors are there in front of us. So it depends on where we are going to apply, or it depends on our choice which surface we are going to make it a reflecting one. If the hollow one is a reflecting one, inner side, it becomes a concave. If the outer one is a reflecting one, then it becomes a convex mirror. So we'll see a little more deep about the convex and concave mirrors. Now, concave mirror. The concave mirror is a spherical mirror whose reflecting surface is curved inwards. faces towards the center of the sphere is called the concave mirror. So when we draw a concave mirror, so we generally choose a shape like this, and we make the outer surface rough one. So we indicate a concave mirror like this. So the concave mirror has the reflecting surface towards the center of the sphere. Now this is the center of the sphere if the imaginary sphere is there. So the reflecting surface is this one toward the center of the sphere. So that is how we are going to indicate the concave mirror. Then the convex mirror, the spherical mirror whose reflecting surface is curved outwards. So I'm going to choose in a regular, so there is a notation or representation for convex mirror. So this is a curve, and we are going to make the inner surface coating in the inner surface so that the outer one reflects. So this is the outer, so curved outwards. So this becomes the reflecting surface or bulge surface. So outside, so this will be our center of the imaginary sphere. Okay, so I'm going to mention it with C here. So we'll see some more important terms in this spherical mirrors. So the aperture is nothing but the effective width of the spherical mirror from which the reflection of light takes place. It's called the aperture. So generally when we are going to represent a convex mirror or a concave mirror, so let me draw a concave mirror. So that's a part of that's the concave mirror. So for the concave mirror, this one is the reflecting surface. So this is the reflecting surface. For a concave mirror, this is the reflecting surface. So that becomes the reflecting surface. I'm sorry, yeah, good. So this width is called the aperture. So in order to have a clear understanding what exactly this is, what I'll do is I will copy it from the above one. So from this, so this part, so I'm going to bring this part, so I'll place it in front of you, so that part, so that you can understand it more clearly. So this one, so that's our small spherical sphere, spherical mirror. So then spherical mirror generally are circular in shape. So for this circular reflecting surface, this width, so this width is called the aperture. So the effective width of the reflecting surface, or sometimes it can also be considered as the diameter. So that's the diameter of the reflecting surface can also be considered as the aperture. It's the same. Like if when you consider either the convex mirror or the concave mirror, for both of them, it's the diameter of the reflecting surface. Next term, it's the pole. The pole is nothing but the center of the reflecting surface of the spherical mirror. So when we take the spherical mirror, either convex or concave. So that's the concave mirror. So when I take a convex mirror like this, so for any of these spherical mirrors, so the center of the reflecting surface, so exactly that will be here, the center or this center. So this center, the point exactly which lies at the center of the reflecting surface is called the pole. So for you to understand, what I'm going to do is the front side, the reflecting surface I'm going to draw. So that's the spherical mirror. So for this spherical mirror, exactly the midpoint of the reflecting surface, we call this midpoint as pole. Midpoint of the reflecting surface is called the pole. So in the next class we'll see the remaining important terms of the spherical mirrors in the spherical mirrors. Till then, take care. Bye bye.